Hi guys, welcome back to Porter's Network Room. Welcome back to VLAN Part 2. So in this Part 2, as we had talked about earlier, we're actually going to talk about inter-VLAN routing and question why are we actually routing between VLANs. So we're routing between VLANs for us to actually share resources. I've got a topology for you, and guys, it's a small topology, and suppose we've got two switches in this building, and we have partitioned these switches to actually have some VLAN 10 and VLAN 20, VLAN 20. And suppose that we would want to actually have a server. We've introduced a server here, and we want all users to access this server. Let's say this is a web server. Well, this server, when we actually look at it here, it belongs to VLAN 10, and this is its IP. So if I were to go to a PC that is in VLAN 10 and will have to access the server, I'm able to. You see that? But if I were to go to a PC in VLAN 20 and try to access the same server, I'm being timed out. Just wait for it, it's gonna time out. Okay, so why would we want to access the same web server? This is actually for resource actualization. We cannot afford to put web servers and file servers in each and every VLAN that we create. We're supposed to actually have resources being shared in the enterprise network. Okay, so guys, I would love us now to have to draw our focus to this router here. So this router here is a router that is actually going to route our packets between these two VLANs. And we don't need to have any IP addressing on this interface. What we just need to create are the sub interfaces. One thing that I need you to note is that we've got two methods for us to actually do inter-VLAN routing. The first one is what they call router on the stick. Well, according to our topology, as you can see, it doesn't look like router on the stick, but the functionality are the same. So we're actually going to use a router in this first part too. Then we're going to look at layer 3 inter-VLAN routing using SVIs. So let's dig into it. Before we actually create our sub interfaces, we need to actually look at our configurations on the switch. And if you can actually look at this, we've got VLAN 10 for sales, of course, we've got VLAN 20 for engineering, we have a parking lot. Actually, we should even push all these interfaces to the parking lot. We don't need any interface. You wouldn't want to have any interface in the VLAN 1, guys, for security reasons. However, there's a simple lab and we're concentrated on how we are supposed to inter-route. So let's look at this. So the first one that I'll actually concentrate on is VLAN 10, 20, and the native one, which is 40. Okay, what else? I would also want to concentrate on uh, on the actual VLANs and their gateways, because now we're looking at a layer 4 device, and a layer 4 device only communicates with IPs. It doesn't communicate with MAC addresses like a switch. So we are having 10.2 for VLAN 10 addressing, and for VLAN 20 we can see it is 20.2. So we're going to go to the router here, go to global configuration mode, and we're going to go to the interface FA0/0. What we need here is to enable it. Sorry, we're going to issue a command called no shot. Oh my god, what is going on here? case, so let's say no shot. Okay, we actually had moved out of the interface here. That's the reason why we're having a challenge. Just read our code here, our console. We had moved out of the interface once we made this mistake. So let's get back to it. Interface FA 0/0 and do a no shot. Awesome things. Actually, let's go back to the forgot to do something on the switch. I would love for us to actually finish up with the switch first, and we're going to go to global configuration mode, conft, and in global configuration mode, guys, what we're going to do is to actually go to the particular interface that is bridging the switch and the router, and that is FA02. So on FA02, what we're going to do is we're going to tell it to be a trunk port. We need to actually have it trunk. So we're going to say switch port mode trunk, and we're going to actually allow all the VLANs to pass through, or we can allow specific VLANs. So we're going to say switch port trunk allowed VLAN. So we can say VLAN 10 and VLAN 20. The parking lot is not necessarily VLAN 40. So we have actually just allowed all these type of VLANs to actually access us. So what we're going to do here is to save our configurations, and we can actually do show FA0/2 switch port to show interface, and we can see to say that we have only allowed these VLANs, and we can see to say that it's trunking on native VLAN 40 and it's a trunk. So the command is show interface, the interface name, and switch port. So this is the shorthand of switch port. We actually had done these commands in the previous episode. Okay guys, so let's go and finish up. So on the router, this is where our magic is actually going to happen. One thing that we need to note on the router is that we're actually going to only create sub interfaces. So we're going to create sub interfaces for VLAN 10, VLAN 20, and VLAN 40. So what we're going to do on this is we're going to exit here, and we're going to go to interface FA 0/0.10. You see that we have line protocol for the interface of this sub interface. Change status to up. So it has been created. The next thing that we have to do is to have our protocol described, encapsulation.1q, and we need to put the VLAN ID. If we actually do a question mark there, we can say that console is telling us that the next thing is the VLAN ID. So we're going to put 10 there. So we're going to put our IP address into these sub interfaces, and IP address is 192.168.10.2. We're using a subnet mask of 255.255.0. You can exit out of this interface and create the other interface, interface FA 0/0.24 VLAN 20, encapsulation the 1Q, and the VLAN ID is 20. IP address is 192.168.20.2. 255.255.255.0, and we're exiting out of this. Then we create our last sub interface FA 0 slash 0.4t, and this is actually for our native. We talked about the native VLAN in the previous video. Please, if you didn't watch the VLAN part 1, I would highly encourage that you do that. Okay, thank you. So on this one, on our encapsulation.1q, we can actually give the VLAN ID, and if we do a question mark, it's telling us make this VLAN native. So for this one, you need to actually issue that command for the router to actually know that this is actually a native sub interface. So what we're going to do is that we're going to exit out of this. We can save our configurations here, and the next thing that we would want to do is now test if VLAN 20 is able to access the file server. So when we actually add checked, we were unable to just get the IP for the file server. We can go here. Firstly, before we access its website, I'd love to actually ping it so that I should actually have the app request already in place. The first ping should actually fail, and the first ping failed because we are actually trying to discover the MAC address of the router from this PC. We're going to talk about that once we talk about IP services. It's a very interesting topic. We're going to talk about the OSI model, and we're going to talk about the TCP model and how data encapsulation is actually happening at each layer, from layer 1 all the way to layer 7, from layer 7 all the way back to layer 1. So we can go back now here and try to access the website. You can paste the IP there, and as you can see, we're now able to access the file, the web server from both VLANs. So this was actually inter-VLAN routing using a Cisco router and a process called router on a stick. In the next version of this series, we're actually going to talk about SVI and layer 3 routing, and I hope that you guys actually will be present with me as we actually unfold that. For now, if this video was so resourceful for you, please hit the like button, do hit the subscription button so that you should be able to actually watch the third video, and be there next time we meet again. Thank you very much. In the meantime, you have a good one. Shalom.